Good evening to one and all present here. It's my pleasure to welcome you all for the day 2 of Faculty Development Program on Navigating the Green Revolution, Integrating the Electric Vehicles and Hydrogen Fuel Technologies for Sustainable Mobility. I would like to express my warm greetings to all the esteemed faculty members from various institutions who have joined for today's session. Your enthusiasm and commitments towards the continuous learning truly reflect on your academic excellence. A special welcome to our distinguished resource person who has agreed to share his expertise with us. We are truly honored to have you with us, sir, and look forward to an enriching today's session. This faculty development program is designed to provide a game changing solution to ensure the access of affordable, reliable, sustainable transport through green energy for safe and resilient operation in alignment with Sustainable Development Goal 7, that's meant for energy, and 11, that's meant for transport. To attain the sustainable development goals, we have to adapt the electric vehicles and hydrogen fuel technologies by reducing the greenhouse gas emissions and improve the air quality. In addition to that, we have to enhance the infrastructure by improving the efficiency and affordability of sustainable transportations. To meet out the objective of faculty development program, today we have planned to organize the lecture on EV components and designs. So now I would like to introduce our today's first session resource person who is a distinguished industrialist who has completed his bachelor degree under the stream of electrical and electronics engineering at KLN College of Information and Technology in the year 2016 and completed the PG course on high level embedded system design at Bangalore in the year 2018. Then he started Quantanics Techserv Private Limited in the year 2018. His prestigious clients are Titan, Nokia, Stematic, and EXT. He has trained over 50 plus instructors and 5,000 plus college students across India, including the premier institutions like NIT, DSC, and TCE. He has mentored and supported new startup in recent technologies such as IoT, AI, and machine learning. Acted as a mentor as well as trainer for Startup India project, and his team won first prizes for 2 times for Startup India project. Also, he conducted various conferences, workshops, and hackathons to foster innovations and collaboration. His expertise in the field of high level embedded system design, Internet of Things, he is mentoring and training for starting a startup, and he is conducting a technical events like hackathons. The such a wonderful industrial resource person is among with us. He is none other than Engineer A. Kesavan, CEO of Quantanics Techserv Private Limited, Madurai. So I invite the resource persons to deliver the first session on the topic EV components and design. Without any further delay, let's begin the session and wishing all the productivity and insightful learning experience. Now I request Engineer A. Kesavan sir to handle the session. Sir, please.
Yes, ma'am. My voice is audible right now.
Yes, sir.
Yes, yes.
Yeah, thank you. So thanks for having wonderful opportunity to us to deliver the TV components and design to discuss with young people like you. So we are going to discuss about the agenda about what are the components involved in the electric vehicles and what are the software for the development and designing purpose to derive that electric vehicles. So these are the two categories we are going to discuss about that. So before that, we already have an intro about what is Quantanics. So we are from Quantanics Techserv Private Limited. So we do embedded system, IoT, and AML and the chatbots. These are our domains. So before going into the components, so we have an overview of this vehicle. So electric vehicles, whatever may be the two-wheeler and three-wheeler and four-wheeler, the basic concept of these vehicles have the batteries and then motors and the transmission systems and then converters and the BMS and the controllers. So have these components are the play major role. So we are going to discuss about detailedly what are that individual components and how to like derive from that one matter to another matter. And what are the important factors we need to consider that. So these are the topics we are going to discuss right now. So the component and design, these terms are the important terms we are going to discuss. The first one is traction battery bank, and then DC to DC converter. This is the most important term. Another one is motors and batteries, charging ports, non-board chargers, and the auxiliary batteries. And what are the importance of auxiliary batteries? We are going to discuss. And the important one is thermal systems and the transmission. These are the segment we are going to detailedly discuss about that. So have a little bit of like this is an overview. We are going to discuss deeply in the next upcoming slides. So first we are going for like a transmission powers, like a transaction power systems, the batteries. The batteries is the electric vehicle. The key play more role is that EV is the battery. So there are nowadays is a lot of batteries available in the market. The research is also going on like so salt-based batteries and like graphene-based batteries are nowadays research is going on. But marketly is available is lithium and lithium ferrophosphate batteries is nowadays is available. The solid state battery is also available for the low cost. But uh, major play important role is lithium. Lithium is a play important role in the battery bank and have a range of 48 volt. It's have a cooling system of air cooling system and the liquid cooling system is available for that battery bank. And the electric motor, that is lot of motors is available for the small application to high level application. For example, if you have a huge number of like more number of vehicles have capacity tonnage have like 4 ton and 5 tons have capacity vehicles have more number of batteries motor systems is available. For example, the AC bus and then truck and then nowadays it's going for the trains is also available. So these are categories of motor, wide range of categories of motor is available. But common scenario is that permanent magnet synchronous DC motors and PLDC motors and the induction and then axial flux. These are the major motor categories. So we are going to discuss about that. And that power performance is under that 5 kilowatt, it's a e-bike, and then more than of 350 kilowatts, it go for the electric vehicle. And the motor controller, the main component of categories is converter, the DC from the battery to motor or directly battery to that converter and then directly battery to that motors. So it's a motor controller and inverter is important term and the onboard charger. So it's the main important terms and the regenerative braking systems is one of the interesting factors. In the electric vehicle design consideration, the major part is the chassis and body design. So chase and body designs is conventionally what we are having in the market. Presently, we are accommodated with one. For example, if you want to buy a Tata Nexon from petrol or Tata Nexon from EV, that both in body chasing infrastructure is both are similar. So more or less 90% is similar. Under that battery laying and then cooling laying component only the difference between the chasers from the conventional petrol vehicle to electric vehicle. So majorly the 90 to 85 percentage of chase and body design both are same. That comes with aluminum or carbon fiber. Nowadays, composite materials is also now available. For example, in the conventional system, the heat transmission component is not that much of consideration efficient. For example, if the engine get overheated, it not that much of an impact for that people. But if you are going for the EV, the heat dissipation is very important factor. So the chase and body design should be heat relevant composite material should be the consideration. And then the aerodynamic structure, as usual, what are there available in that commercial vehicles like normal petrol diesel vehicles, that same aerodynamic component structure is also available. And the battery replacement holders, the connectors, and the charging port pointings, and then wiring harness diagrams and wiring harness motors. These are all that conventional system difference from electric vehicle to our vehicles. The thermal management systems have a lot of thermal management systems is available. So the cooling systems for that mainly for battery and then motor. So these are two important factors for the TV. So majorly the motor, it's an aerodynamic cooling system is preferable because we are not having that much of cooling systems are not important for that motor purpose. So, but most important term is battery. So we must consider the thermal management system for the battery and then charging circuits. So another like control and safety systems of vehicle control unit is how the normal conventional engine system or OBD port will be the onboard diagnostic. Same thing have vehicle control uniting systems available for the electric vehicle, and the same adapt features, AI driving assistance, land assistance that are similar to both of our same. So before we are going to the component, first we derive with what are the EV software for the testing. So first BMS. So BMS have an important term in that electric vehicle because both charging and discharging is a main important factor for that electric vehicle. So the first term we go for that lot of software is available. The majorly the AutoStar. That is the standardized automotive software architecture. So what that engineer do mainly testing for the BMS is they go for that AutoStar. So and then not only for that, also a lot of onboard own development software is also available for nowadays. For example, the Nexon have own development BMS software will be there, and then Toyota is the pioneer player for the EV. The Toyota have a own BMS software testing product is available. So individually they are having one, but these are all for the development purpose and the researching purpose. We can go for. And the VxWorks is a very important thing. We can go for that testing software like battery management system testing software. And QNX have dedicated OS will be there. Like there is a Linux based OS will be there. That QNX have a real-time operating system and inbuilt OS will be there. That integrated virtual interfaces models also available. So how much of charging currently going, how much of discharging for that battery to motor, and we can use as a weather for like a forecasting purpose is also available. Load forecasting or like how in which kilometer battery bank percentages wise we can go for how much of percentages going to next station. These type of options available in the QNX software. Next, motor control software. Yeah, my voice is audible. Is there any interruption? Please ensure me. Any one of you.
Audible, audible. Yes, sir, you are audible.
Yeah, yeah. Thank you. So next, motor control. So I already told that a lot of motors is available the based on that size and based on that load and based on that cost. So especially motors is also available. So basic commercial vehicles have a PMS and BLDC motors. So we can use as a software like as a MATLAB or Simulink or whatever it may be. So and then power electronics and thermal modeling software is available. So that is very good important software for derive what happen inside the motor. For example, like once we are applying that hard braking. So once we have hump and dump in the road structures, what impact in the motor shaft or what impact in the motor load, so it can easily understand. The lot of algorithms also default free algorithms is also available, or else we can also derive the algorithm like FOC and a lot of algorithms is available in the predefinitely they are available in this software. But if you want to, we can also optimistics. We can override the algorithm and we can integrate two algorithm into one, or we can interface from one algorithm to another one. So these type of applications is also available in nowadays. So I already told that this is how the OBD for normal conventional vehicles. So same as the vehicle control unit for the electric vehicles. So it will maintain the overall performance of the driving mode. For example, in which time you are start the engine, or which kilometers you are performing today or tomorrow. That all the log or performance in that vehicle control unit. This vehicle control unit will give the information about that vehicles and then users. To ensure the which performance of the electric vehicle, so I can easily get the data from a vehicle control unit. So like how similarly our conventional vehicles have a OBD port, so same as that. So I can easily identify or easily understand my vehicles, what happened inside that battery, what happened inside that motor performance, and how the driving board performance will be there, and how long the battery capacity is going for next upcoming days. So these are terms we can easily get from a vehicle control unit software. This is also like a lot of open source software is also available, but mainly the AutoStar. That the AutoStar is a standardized software that mostly all the automotive vehicle companies use this software. For example, Mahindra and that Nexon, all the companies are using this AutoStar based softwares. So these normal standardized firmware will be there. How that embedded protocol like I2C, what same as the standard protocol framework will be there. we can use this framework connected with our existing like converters, batteries, motors, and then BMS, everything we can connect with the electric vehicle control system. So these are all the major softwares. Another one is charging and energy management software. This differ from BMS. So BMS played that important role for charging and the batteries. And this main energy management software is for onboard charging system. The onboard charging system means I represent as AC to DC or else like DC to DC. Have a categories will be there. So it's responsible for the running time management system. The BMS is have a charging time and discharging time, and this onboard charging management software is mainly responsible for like moving time responsibility. For example, if you are coming from hill station to down station, the regenerative braking system will occur. At that time, the charging will be get from your motor, and the power will be stored from that battery. So this time, what are the performance analysis happen inside the vehicle, we can easily understand the softwares. So these have a lot of protocols will be there, and lot of softwares will be there. And not only for that regenerative charging system, we can monitor as vehicle to grid or vehicle to vehicle transmission system. Also, we can manage this type of software. So this is similar. This is not similar from BMS. The BMS is different, and this one is the different. This one is the running time and regenerative braking system, and then vehicle to vehicle transactions and like vehicle to grid transaction system. What happened inside that vehicle or what happened outside that charging ports. So this scenario we can easily understand, use these softwares. And then safety diagnostic systems, like it's like open simulation system model. So how that crashing works on how that vehicle can response for that immediately, for example, if you have immediately have harsh braking from one point to another point, what happened inside that motor or inside the transmission system or inside the batteries, what will happen, we can easily understand. This scan analyzer vector tool will be there. This can connected with the vector network testing system, which have a lot of open library models is also available, and you can also create it for this one. This is also the functional safety and the cyber security connection purpose. Mainly for that internally and external vulnerable, we can avoid that this diagnostic tool. For example, if someone have vulnerable attack from someone else from one car to another car. For example, imagine the scenario: you have a two charging vehicle. So you can now one vehicle have a low battery, another one have a huge amount of battery. So now you are planning to change that power from one vehicle to another vehicle. So you are going to connect one electric charging port from one port to another port. So at that time, the software will play the important role for that security vulnerable thread and connecting from one port to another port. And the diagnostic software is also available. So a lot of diagnostic is available in nowadays. It's like our mobile phone have a lot of diagnostic system. So same technology happen here. So it's have a lot of tools, diagnostic port. What are the ports available in that? If any other fault occur, we can easily have a error code will be appear on the display. That error code have connected part number. For example, if something occur in the regenerative braking system, or like charging port have a problem, or charging port have a disconnected from in between, or wiring harness have a problem inside the vehicle, you can have error code. That error code will show on that display. We can easily track the system and we can easily clarify that. The user interfaces software is also available. That's similar how the HMI will work, same as that. Have a in if you are seen in that XEV3 XO or XEV700, that there's a huge HMI panel will be inside that front of the driver. That will show that navigation. That will show that how much of tire pressure and what are that scenario happen, charging, discharging, and then like a lot of sensors is available nowadays. That sensors data all the feeder to the HMI display. That HMI will play that user interfaces, like similarly how user interfaces. So these are all that software categories we are discuss right now. So if you have any other queries regarding this software, we can have a discussion, or else we can move to the next one. Okay, so I can move next one. At the end of the section, we can discuss about this software. If you have any other queries, we can discuss detailing. So next one is the type of vehicles. We already know that the purely battery-based vehicle, hybrid vehicles, and then plug-in hybrid vehicles is also nowadays is available. So a lot of differentiations is available. For example, the purely EV means that entirely connected with batteries and run with batteries. Once the battery low, vehicle will be stop automatically. But hybrid-based vehicles means have a small amount of batteries and the combustion engine will be there. So we can switch on the mode for based on the operation, or automatically it will be changed the mode. For example, nowadays is the Trican Innova have hybrid electric vehicles. So if you go for that city ride, like below the 40 kilometers of speed or below the 30 kilometers of speed, your engine will be petrol will be cut off, and automatically that motor runs from that battery systems. So once you go for that beyond the for 30 kilometers or 40 kilometers, our electric vehicle like battery will be cut off, and then engine will be on automatically. Like petrol will be on automatically. So both mode is available. So this is a interesting scenario. That component is interesting scenario. That's another one is like regenerative braking system. At the time the battery will be stored charging. There is no separate charging point for these vehicles. So moving vehicle parts, automatically the battery will be charged. So these are the major categories for the four wheelers. So first we are going to discuss about the BMS. So the major component of that design scenario and then major component of that BMS is that state of charge and rate of charge. That means how much of power you are going to charge that circuit and how much of power you are going to derive from that battery. So this is an important factor to that electric vehicle for performance analysis, as well as battery capacity, as well as motor efficiency. So these three categories are combined with the BMS. So once we have detailed understand of the BMS, so we are touch with batteries, charging circuits, and then load. That means incoming and outgoing, and then performance. We can easily understand that. So what are the type of batteries? Already we told that a lot of batteries researches is going nowadays, but majorly it's a lithium based batteries is familiar for nowadays market. So in upcoming days, it may change for that like solid state, like salt based batteries, or like graphene based batteries also under in the research. Once we are touch with graphene based batteries, its charging time is also very less. It's take of minutes of charging only, have 0 to 100, and then discharging is also very high of power capability, and EC swappability and size is also very less. So on the motor, we already I said that the lot of motors available for the EV research. So mainly it goes for like permanent magnet synchronous motors. Like this is a very efficient as a commercial vehicle. It's a very efficient motor right now. So on the like if you have go for the tricycles and the two wheeler, they go for that PLDC motors, and another like axial motors is also available nowadays. So once we have go for based on that cost and based on that load, we can select one part of the motors, and that motors we can have a performance analysis, and then load characteristics, and these are the terms of involved in the technical point of the view. Power control power electronics controllers. So these controllers play the important role for switching from AC to DC and DC to AC. For example, if you are connecting charge from that EV for our normal conventional grid, that means power as a alternative power system in our home, that AC, that's a single phase. So we have a single phase power supply in our home. But if you want to charge for your electric vehicle, it's a two-wheeler is not that much of problem. But if you are going for that electric car, it's have a main important parameters is power electronic controllers. So these controllers have that manage all that parameters from the grid to battery, and then primary battery to auxiliary batteries also. So we are discussing about the auxiliary battery. That is interesting thing. So these are terms of important parameters. So what are that charging? Before we are going to discuss the charging port. So as a India, we are using that type 2 charging because the type 1 charging of 120 volt, it's have a like so
suitable for suitable for that European country,
like the Northern America, but we are using like European based standardizing system. That's type 2 charging port we are using. So what on the type level, actually I have a three level, the type 1, type
right now. That is type 2. And type 3 is purely DC to DC. That's connected for fast charging mode. It's not for, it's a commercial purpose. If you have a vehicle, you want to drive from Kanyakumari to Chennai, so there is a lot of DC power station is available. A lot of AC power stations, charging stations also available. But commercially, they have private vendors have a DC fast charging models is available. In Madurai, the Kapulur have a DC fast charging charge port is available. So if you want to connect with the DC fast charging, it will take like around 20 to 30 minutes. It's have more than of 0 to 80%. It comes with fast charging mode. It's have level 3, but commercially what we are using majorly the type 2. So the DC port that names for that can demo, that means charge and then go. That's a Japan word. That means charge and go. It's a typically have a high capacity of charging speed and high capacity of power rating and high capacity of current conductance. So I have a lot of protocols similar to that. So what similarly how our mobile chargers have Type C, and then like Apple phones have a normal conventional micro USB. So same as that in happen. So it's have inbuilt have a protocols will be there. That protocols play the important role in the chargers. So we already told that the onboard charger, that onboard chargers is a important role. It's converted AC alternative current from that our home applications to conventional system like power from that vehicles. So these have the functional parameters will be that the function AC to DC conversions is the main important term, and then voltage and current managements have these onboard charger will have monitoring these devices, and then battery management systems have integrations. So these are terms are connected. All this term as a like in this field they are derived as an onboard charger. This onboard charger of these three parameters are involved as an onboard charger. So in that public infrastructures have like normal conventional type 2, and then like sorry, in our home I have a type 2 chargers, and the public have DC also nowadays is available, and the normal they are also having that type 2 AC power chargers is also available, and the smart chargers is also available. For example, they are using that renewable energy system. They have a solar, and they are connected with batteries or whatever it may be. Sometimes it's have on grid systems is also available. So this is a interesting scenario for researching purpose. For example, if you are doing researches in that charging infrastructure that have connected with renewable energy, means have on grid and off grid for that electric vehicles is interesting parameter. So if you have a battery, its cost is also very high. So at that time you can charge from that battery, and from the battery to you can feed from that charger, and then directly feed. They have two-way system. Once you are connected from AC to DC, and then again DC to like battery system, or else you can directly charge from battery to battery. It's also possible. So a lot of technology behind that. So this parameter is an important parameter inside that vehicle. That is DC to DC converter. That is a curious role in that managing the electric power flow between voltage systems of the vehicles. So what happen? What is the important parameter of these vehicles is to have a battery in our vehicle. So and then like our motor system will be there. So between batteries and then between motors, the key player is DC to DC converters. So these converters have that functional parameters of that step down, and then like voltage from that battery have a huge number of power, and then giving back to the step down and the power, and then input feed to that motors. So once we go for that motors a high number of performance, for example, if you are going for 40 kilometer speed, that's not a problem. Suddenly you are going to rise that speed ratio from 60 kilometers to 100 kilometers or 120 kilometers. That power fluctuations is very important from the battery to motor. So what happens? These contract between 60 kilometers or 40 kilometers to 100 kilometers or 40 kilometers to 120 kilometers. So these conventional speed variations, so important parameter manages this DC to DC converters is the key player. So this player will have battery source getting the data, getting the power from that battery, and then give that how much of a threshold you are pressing from that your vehicle, that give to that motor. In the outside have a heat ventilator, air ventilator, other type of cooling systems is also available. In that electric vehicle, the primarily 50% of the accident occur for that battery. Another 50% accident heat sink is occur only for that DC to DC converter. So these are that important system for that electric vehicles. So please ensure my voice is audible, ma'am.
Yes, sir.
Okay. Okay, the component of next have DC converters that have converting circuit, similarly how that converters, the MOSFETs will be,
but MOSFETs will be there. The technology have very interesting things. So next one is auxiliary battery. So these 12-volt auxiliary batteries have differed from normal batteries. For example, the vehicles have primary batteries, that is a conventional electric batteries, but these auxiliary batteries is for the backup batteries. So this is responsible for all that electrical components like HMIs, and then switching devices, and then charging circuit for BMS, and then onboard charger and vehicle management system, VCM control unit. These are different controls units are there, and then sensors, and then headlamp, and then your audio systems playing will be there. So these are all the important parameters. The battery source is auxiliary battery. This is also secondary battery. Similarly, we say as a secondary battery. So in conventional system, like in hybrid vehicles, this is a primary battery. For example, the hybrid vehicles, Innova have hybrid vehicles. In this hybrid vehicle, that auxiliary battery is a primary battery. So as power get from the regenerative mode, or else a gasoline power is also charged. We can charge it from here. So it will play that major role in that hybrid vehicles, like plug-in vehicles or hybrid vehicles. So it support 12 to 48 volt. It's based on that capability and based on that power. So at that time, we can switch from 12 or 24, whatever it may be. It's based on the performance and based on the cost wise, we can design. So I have a backup power from this parameter, giving us if any other fault condition occur, or if any other isolation purpose we need to done, this battery power will play that important role. For example, if any sudden power will be occur, like any fire will be occur in that electric vehicle, we need to switch off, or we need to breaker will be on automatically. So at that time, auxiliary battery give the power supply to this unit to isolate all that electrical parameters, to ensure our safety and production, protecting the other parts of the component to reduce the fire and heat dissipation. So next one is thermal system. So for thermal system is important parameter for the electric vehicle as a design, as a selection process. Because the major complaint of the electric vehicle, the people point of view, the electric vehicles have. It shows try to reconnect. Is it okay? Everything?
Yes, sir.
Is it okay, sir? Voice is audible?
Okay, sir. What is audible?
Yes, sir.
Audible, sir. Audible.
Okay. So in the thermal system is an important parameter for the design and the selection process. Majorly, the customer point of view, as a layman point of view, the electric vehicles have
Sir, you can continue. Yes, sir. No issue. You can continue.
Okay, the slides is not changing, I think. So I have a thermal system slide, but
Yes, sir. We are viewing a thermal system only. Types of.
okay. Only one. Okay. So I have a so yeah, thermal system is important parameters for the design purpose for the electric vehicle, because the people are thinking about that electric vehicles have fire accident occur in the news readings, or they are well aware that. So for the thermal system, it's a very important role. The lot of research is also going in the only the thermal point of the view, because once we have our like we are in the tropical zone, so we have a like moderate of 12 hours we have a day and 12 hours we have a like night. So it may differ from heat difference from one unit to another unit. For example, if you go for that north, the daytime the heat is very high. At the similarly, the day and at the night durations of time, the colds are also very high. So at that time, how our system, like how our batteries and how our system will be react, that is a more important thing. At that time, the thermal system is very important. So nowadays, they have three systems. That is liquid cooling system and air cooling system, and the like phase charging material. The phase charging materials is similarly heat dissipation from one material to another material. Like it's purely depends on material sense. Like aluminum based phase discharging materials is available, and nowadays is carbon fiber, like fiber based thermal charging materials is also available. So it's have a lot of research is doing in that phase charging material. That's a material. Similarly, how the iron and how the aluminum will be works. So a lot of research involved in this phase charging material. So these three categories is a play major role for ensure that thermal safety. So not only for the thermal testing, they have a sealing purpose is also available. So how our electrical devices seal for the leakages, for that we are using epoxy rexing or some other rexing purposes are available for seal our ICs for the short circuit or that preventing the security. Same nowadays they have a open source like IP rated like casing will be there. That casing insidely entirely sealed from the inside that the insulator. So once the fire occurs, that fire will be inside that casing and inside that component. But it will be have little amount of heat for that outside that body. That much ensure the thermal safety insurance. So another one is like EV charging components. It's another one role. So EV charging components have lot of components will be occur in the EV charging. Like normally conventional system will be there, or else a commercial based vehicle system. Nowadays is ONGC and then Bharat vehicles and then like HP. They are planning to install that EV charging station in that petroleum pumping station. So that will connected with grid. That's a like a three-phase power system. So that is also nowadays is available. Or else if you are go for that private based vehicle system, they have two modes will be there. One is DC, another one is AC. So for fast charging, the cost is also high, and then like AC charging, the cost is also nominal. So these are all that differences will be there. Inside the charging station have like lot of circuits will be there, MCB, how that our conventional panel works. That same thing, the like ELCP and MCB, and the breakers will be there. And then if you have any other such productions, that charging station must be ensure that vehicle should be safe, or the vehicle charging point or BMS should be safe. For example, if any other problem occur in the charging station, inside the charging station, so that will easily impact to our vehicle also. That means our BMSs also get damaged, our batteries also get damaged at similar time. We cannot know how much which fault occurred from that point. So similarly, how that petrol and diesel have a quality. So for example, if you go for the HP petroleum bulk or Indian Oil petroleum bulk, so how we cannot exactly know how that petrol tank cleaning inside that station. So it may have some sludge will be there, have some dust will be there. The same thing happen in that that's a EV charging station. If any other fault occurs from that inside the charging station, that will not affect our system, like our vehicle or our BMS and our battery should not affected. In this scenario, I have a lot of ensure will be there that on vehicle we already discussed about that vehicle management system that will ensure that whether the charging is safe or not, whether it's any other harmful from the inside from your third party charging station, automatically our breaker will be cut off the point it shows the error. So some other fault will be occurring.
comes for any other problem occur from that third party vendor charging station, our system will automatically detect and cut off that charging time. So these are all the terms, important term. This is not fulfilling for all the product. For example, if you go for middle end of electric vehicle, these features is not available. But if you go for the high end of EV like RDR, like whatever it may be, they have these features. So if anything occur from third party charging station for third party vendor, it will not reflect our electric vehicle, or it not affect our BMS. So so these charging ports. So we already discussed about that. So if you have charging ports of type 1 or type 2 or type 3, whatever it may be. So if any problem occur from the charging side, or if any problem occur from our grid side, for example, assume the scenario, we have a electric car or electric two-wheeler, whatever it may be in our home. So we are going to charge our normal conventional AC grid system. So it's in the durations we are not ensured. It's regularly it comes for the 230 volt. We are not assured that, because our grid system may vary from different month or different zone. For example, if you go for that summer, that demand is also very high. At that time, the voltage is also little bit of low. It's not have 230 volt. It's not ensured that. It may go for 220 or it may go for 210. At that time, we need to ensure our BMS and then ensure our like batteries also. That is very important thing. That will ensure in the point of charging port. So same thing happen in that electric vehicle, four-wheeler also. So once we are going to charge the electric vehicle, we need to ensure proper breakers and then proper charging systems we have. We must to ensure that then only our system will be stable, and then we have a problem will not occur. So we already discussed about the DC charging. So this is not frequently using, because once you are using DC charging regularly, your battery performance will be get like fast charging mode. Once only the fast charging mode, if you are charging the battery, your battery performance is also getting low for normal conventional AC charging to DC charging, because you are rapidly charging that battery nodes. That node will be get affected. Sometimes the node will be get tensions, or node will be get corroded. It will happen. So at that time, the battery bank efficiency will be decreases. So these are the studies happen for the fast charging. That's why as India as a country, we are not preferring for that DC fast charging mode. So everyone, if you are going to buy that two-wheeler or like a four-wheeler, you ask the vendor which one is the preferable charging mode. They prefer for conventional AC system. For the rapid charging mode, it may reduce the battery efficiency, and then battery nodes, and then battery cells also. So after that, we can detailedly discuss about that onboard charger. So this onboard charger as a critical component that convert alternating power, like conventional AC grid system, from that DC grid systems. We already discussed about that vehicle to vehicle transfer system. So once you have a technology for one vehicle charging system to another vehicle charging system, that time if any other malfunction occur, or any other malfunction occur, or any other, we need to ensure that. So at that time, we have three categories of segments. The one is for AC to DC converter. Another one is voltage and current management system. That OBC management will be there. Another one is BMS. So these three components, these three parameters are responsible for onboard chargers. So once any other problem occurs, these three parts will be get affected. So once they get affected, it have a huge impact, like it will have a huge replacement, or it have a huge changes for our vehicles. So it have losses for us.
Controlling and monitoring systems. This is similarly the central point of a vehicle. So like it's microcontrollers are like a digital signal based processor inside will be there that will monitor, that will measure, and that will responsible for all that process. For example, how much of conversion power we need to know, or like how much of power we need to drive from battery to motor. So these are all derived from controller will be there. So this controller will like adjust how much of input parameter getting from the data. For example, if you have a 40 kilometers of cruise control, so that will take us an like 40-kilometer drive from battery source from the motor. So if you are rising power from 40 kilometers to 120 or 100, so suddenly our uh, battery pickup power will be increases. So at that time, the DC to DC converters play the important role and give the data to that motor. So that signals comes from that microcontroller, or a lot of dedicated RAS is also nowadays is available. That RAS play that important roles. That's similarly how that normal conventional system work. That is same thing that. So we already discussed about the auxiliary batteries, and then this is supporting batteries only. But in the hybrid vehicles, this is the important battery, for hybrid system. That's have charge from two-way system. One is from the normal gasoline. We can also charge from that running system. How the gasoline system will be work. How the nowadays is how the car battery will charge. That is same scenario. Or else regenerative braking method is also charging mode. So it's have a told or 48 volt battery will be there. That will be work for the hybrid system. For only for the hybrid vehicle for the primary battery, and EV battery is for that auxiliary system. That will responsible for that supply for sensors, and then like controllers, and then like RAS systems, and then like BMS. These power supplies. These are all responsible for these auxiliary batteries, and the main battery is not main battery is not disturbed for this one. So mainly the main batteries is only for that motors. The another remaining all these audio systems, and then like lighting, and then like sensing sensor unit, and then breakers, and then like BMS. These are all power supply for auxiliary systems. So before going to conclude, so the lot of opportunities available in that electric vehicles. So electric vehicles have not only for that electric vehicle technology that will migrated from four two-wheeler, and then like three-wheelers, and then four-wheelers. Nowadays, bus is also available, and then in the future trucks, and then like if you have in the battery technology evaluated, we can it's possible for that the aviation systems is also available. Nowadays, drones is also available, and then the futures even the ships is also can go for that electric based ships is also possible, because based on that battery resource and based on that motor resources. So once we go for this, we can entirely connected with smart things. So once we go, it may next level of this go for that renewable energy based all the things may be converted. Like a charging station, we already discussed that once we have a solar panel or have a wind source, so a charging station may on grid or off grid is also possible. So that is also happen in the future upcoming days. Have a huge number of markets and huge number of researchers can possible terms in this, particularly the electric technologies. So these electric technologies not only for transportation purpose, even it goes for that like next level of life life changing applications, how the transportations work. Same things which happen for that in that manufacturing sector. Like if we have a technology, same technology we can integrate it with next level of movables of vehicles, like how that machineries work, same technology we can also integrate it. For example, if you have like a production unit in your plant, the same motors, and then same batteries, and then same BMS, and then same charging circuits play the important role. For example, the plastic molding injection we can have. we can migrate this technology to that one. And then like turning center, like conventional lathe machine will be there that have alternative current, the DC current, AC current will be there. So same technology we can integrate it into that particular applications is also we can migrate it for DC based lithium battery based machining systems, like on conventional printing system. Printing machines have a lot of machineries in the textile industry. Same. What are all that AC devices performing nowadays? We can migrate it for that DC. So once we migrate for the DC, that battery play the important role. So once the battery occur, that charging will be occur at the same time. Once the charging will be occur, the BMS will be play the important role. So these technologies have a lot of markets and lot of future opportunities will be there for the smart devices and the smart technologies. So once we have that research in this particular fields, have a huge career and then huge industry scopes will be there. So if you have any other queries, we can discuss next 20 minutes. Or if you want to understand early, we can discuss.
Yes.
Yes, sir.
Yeah. So you said that when we charge a two-wheeler to DC bus charging station, so it will affect the lifetime of the battery, right?
Sir, your voice is little bit lagging. Can you
No.
repeat one?
Yeah. Yeah. You said like a DC bus charging station. When we charge the DC bus charging station through for a two-wheeler, so it will affect the battery lifetime, right?
Yes, DC to DC, directly from DC system to the fast charging mode. Only the fast charging mode.
Yeah. Can you explain what exactly it will affect?
In the fast charging mode,
Yeah. Correct.
yeah, it's a very simple thing, sir. Understanding if you are working in the if you are in the running race. So if you are running race have a 1 kilometer or 2 kilometer. If you are traveling constant speed, that is constant speed of for 5 to 6 kilometers. You are jogging for up to 2 kilometers. That means you have a constant drainage or constant speeds will be there. Suddenly you can charge. You can take the speed for another 1 kilometer. What will happen in our body? So we get over dehydrated and we get over strain our leg and we get over pain. So same thing happen in the BMS cell. The battery is connected with a group of cells batteries, right? So
Correct.
that cells have over contracts over like the charging and DC charging, these fast charging and the DC discharging means charging and discharging means it's get over more number of ions will be traveled from one particular nodes to another particular nodes. So that time, what happen? It may get that that temperature will be rise at that time. So fast over fast charging.
So then
So
that
once
means
the
we can,
temperature will be,
yeah,
sorry,
carry on, carry on.
sir, can you repeat?
Yeah, you said you are saying some, you are continuing, so you continue, then later.
Kesavan, sir.
Sir,
Your
Charles,
voice.
can you, sir, the last queries are not getting clearly. Sir, the voice get not clear.
No,
Your
you are saying, you are saying, but instead of in between, I got interrupted, so that's what I said. You continue, then later I will ask.
Okay, so the main point is the battery degradation. So once we go for that fast charging for DC mode, the battery get over degradation. So once we get over degradation, the efficiency also, lifespan is, and the cyclic time also very less. So that only the term for that battery get degradation. So another one is space construction. For I have told that from cooling system. So the cooling systems is mainly designed for like normal convention, limited set of parameters of voltage. So once we regularly using the DC charging system, your thermal like your heat dissipations of battery continuously get over high. So at that time, your thermal expansions get sometimes failed also. So that will causes that like a fire accident or whatever it may be, it may happen. So that's why similarly, electric vehicle companies are not preferable for DC charging. That means rapid fast charging.
Then the rapid fast charging is suitable for which vehicles? Sir? It is only for four-wheelers, not for two-wheelers.
I'm right. That I'm right, sir.
No, I'm asking that you are saying that so DC fast chargings are not suitable for two-wheelers. So it is only suitable for four-wheelers.
Sir, no, this lithium-ion technology only if you go for another type of battery, the fast charging characteristics may different. But if you go for lithium-ion based charging, the fast charging have reduced the lifespan, and then heat dissipation is very high. This lithium-ion characteristics.
Okay, especially for the lithium-ion batteries, right?
Yes.
So whether it will be a two-wheeler or four-wheeler, it is not even.
No. It's not a two-wheeler or three-wheeler. It's not a term. The battery is important term.
Okay, correct. Okay.
Applications is different. Applications is not a matter.
Then why we are moving for the DC fast charging?
So it's only for that preferable for emergency situations, not for all the time.
But the government is also saying that to go for the DC fast charging compared to the AC bus because of the cost, whatever the installation cost is, that is very much high in the AC bus compared to DC
Yes,
fast charging.
yes. Compared to DC, the cost is very high. Yes, but
so that's why governments and even in the Teslas, they also using the same.
yes, sir. But currently, we does not have that much of fully capacity of technology for control this problem statement.
Okay, in
but
India,
we have
right?
Once we get the infrastructure, in our environmental.
Okay, fine.
So once we get this infrastructure, have another type of battery suitable for that will works.
But Tesla is also running with the lithium ion.
Yes, sir. Yes. They are also using the DC fast charging mode. But compare, we are in the tropical zone, no? So we have here thermal dispensation is very high.
Okay, fine. Due to the region aspects, the temperature.
Yes.
Okay.
Yes, sir. Yes.
Okay. Thank you.
Thank you. So, any other interesting queries we can discuss regarding that?
Sir, you can discuss about our EV vehicle topic.
Good evening, sir. Am I audible?
Yes, good evening, sir. Yes, sir, audible.
Sir, can you suggest some good material which can give detailed insight about this EV component design part? I mean, if I want to go in more detail, can you suggest any blog or article or any material?
Sir, you are asking about that frame structure or like thermal, thermal one or
Study material or reference material I'm asking, sir. If you want to
oh,
go,
you are
if I want to go for more detail.
yes, sir. The lot of even the Tesla have Tesla official website. Yeah, even the Tesla official website is also available. That pattern is also that available in that open source. I can share to you, sir. No problem with that.
Thank you, sir.
Thank you. Thank you.
Sir, one more thing. Is there any open source softwares for reliability?
So reliability for what, sir?
Any equipment related to charging, like converters or something like that.
Oh, okay. So similarly, we can go with for that MATLAB. So that's a good thing for testing purpose. It's okay for that. But if you go for any other particularly converter or BMS, means that BMS company will give the software to you. For example, if you buy any BMS from the Texas Instrument, that Texas Instrument have a lot of software for BMS testing. So you can use that software for minimum number of dollars, like more than of $2 or $4 will be there. Only that much of amount you need to pay. So once you pay buy from this software, you can lot of features to integrated these ICs to battery and then load. So lot of softwares is available in the market. So based on your applications and based what you are going to do, sir.
No, I'm asking for the converters, like inverters and rectifiers.
So this one, sir.
Yeah, but in this reliability related softwares are not even mentioned.
Yes, sir. I got your point. Once I get that software name, I can share back to you, sir.
Okay, thank you.
So in the research point of view, we can go for like a vector-based simulink tool will be there. So you can write the algorithm in this platform, and you can connect input parameters and output parameters, and even like DAC card will be there also available there. So that will only for that understanding purpose for general conversion and charging and discharging. So if you go for entirely solution, let me I check with all these things and give the input to you, sir.
Okay, sir. Thank you.
Yeah, yeah.
Participants, if you have any doubts, you can clarify with this.
Kesavan, sir.
Yes, sir.
Sir, you can share more details about the EV vehicle that we are fabricated. That you can
Yes, sir.
share.
So yes, sir. So we already designed that on electric vehicles have small model that is a lead acid battery based vehicle system that's have a like e-rickshaw. So how the e-rickshaw will work, the same things we are already derive in our institutions. So that will have a like open platform will be there. The chase will be designed with a suspension model. So front we have a suspension strain based suspension springs will be there. So on the back side also suspension, load suspensions axle will be there. So and then like
differential axial systems will be there, like how that our e-rickshaws will work. Same thing. It's not connected with directly coupled with battery. So it's have a like axial based systems will be there. One motor, and then I have a wheel. It connected with the back axial systems. So once we get switch on that motor, they have a controllers. These controllers have a wiring harness will be there. That wiring harness connected with batteries and braking system, and then throttle, and then indicators, and then switch on, and then how much of kilometers we are presently going on speeds will be there, and how much of battery presented occur on our batteries, and both voltage and current we are displays on the unit will be there. So let me only one thing, I can share that video also.
The Kesavan, sir.
Yes, sir. Yes.
Sir, we can conclude this session, sir.
Okay, sir. Okay, sir.
Thank you, participants, for making this session an interactive one, and we are engaging with our resource persons and clarify our doubts. I hope the part